Welcome back. I decided to do one more podcast just to review the three rules, right? You've seen them all kind of individually, kind of quickly. I think I did that pretty quickly. So I just wanted to review them with you, and we'll do two more problems together that are in your notes before I close this podcast. All right, so just to review our three rules, we have the product rule. Right, so the log of a product is equal to the sum of logs, right? And that's because when we multiply like bases raised to a power, we add the exponents. And a log is just an exponent. The quotient rule, okay, so the log of a quotient is equal to the difference of logs. Right, notice that's a log of a single product, the log of a single quotient, that's equal to the sum of logs. Right, so we're going to have one log as a product or one log as a quotient that's equal to the sum of all the individual parts, however many parts are in that product or quotient. And that's because so for the quotient rule, right, the log of a quotient is equal to the difference of logs because when we divide like bases raised to a power, we subtract exponents. And finally, the power rule. Right? So exponents can become coefficients in front of a log. Coefficients of a log can move back as exponents, right? Because a log is an exponent. That's all it is. When we're answering a log, we're answering what exponent, right? So we have an exponent raised to an exponent. What do we do if we raise power to power? We multiply the exponents. Okay? Those are our three properties that we learned about. Let's combine a couple of them and do these two problems here that are in your notes, right? So we're going to use more than one rule here. We have a power rule and a product rule in the first one, and a power rule and we can simplify it, and then we have a quotient rule. Right? And simplify because notice we just have numbers there. We can raise numbers to powers pretty easily. All right, so let's look at the first one. Whenever we are simplifying these to condense the log, right, we want to move the exponent back first. Make sure you use power property first when you're condensing, right? You can't condense them now the way unless you move those exponents back, right? I can't make that the sum of the product of a single log because I got a 3 and a 5 in front. You can't make that a 15. That would be so wrong. So wrong. We have to move that back as an exponent. The order of operations, right? Exponents come first, right, before we multiply and divide. And since the product rule is multiplication and the power rule is exponents first. All right, so we're going to move the 3 back. So 3 natural log of x is the same as natural log of x cubed. 5 natural log of y is the same as natural log of y to the 5th. Now that I've moved those exponents, I can take the sum and make it a single log. Right? So the sum of logs becomes 1 log, natural log of x cubed y to the 5th. Right? Since here it doesn't matter whether we use parentheses or not. It's clear that it's the log of the whole thing. But if you want, you can put parentheses. Either way, it's fine. All right, so now we have our next one here. We have 4 log base 6 of 12 minus 4 log 6 of 2. Right? So we have to move the exponents back first. So we have log base 6 of 12 to the 4th minus log base 6 of 2 to the 4th. We can simplify that, right? Because we can raise 12 to the 4th power. We can raise 2 to the 4th power. I don't need a calculator for 2 to the 4th power. Oops. As I'm tripping over the cord here. But I do need a calculator for 12 to the 4th power. So 12 to the 4th is going to give us 20,736. All right, so this is log base 6 of 20,736 minus log base 6 of 16. Right, so I've moved the exponents back, and because these were just numbers raised to a power, I could just do that. All right, now I can take that difference of logs and make it the log of a single quotient. So that becomes log base 6 of 20,736 divided by 16. Well, I don't know how far they reduce off the top of my head. Maybe I do. But we can see they definitely reduce because they're both even. What if we divide 20,736 by 16? Does it go in evenly? Well, while I look at that, it does. So now I can rewrite that as log base 6 of 1,296. And you know, I kind of think that 1,296, it might be 6 raised to a power. Maybe. Let's see. Right? What if we weren't sure? What if we didn't have a calculator with us? And maybe we weren't sure what to raise 6 to. All right, so 6 is 1,296 is divisible by 6. That would go in, well, go into 12 2 times. It would go into the 9 once. I'd have 3 left over. That'd be 36. That'd go in 6 times. Right? I think I know 6 to what power is 216, but let's say I don't know. I think it might be divisible by 6 again. Let's see, maybe. All right, so 216 divided by 6. Well, 6 goes into 21 3 times. I've got 3 leftovers, so that'd be 36. 6 goes into 36 6 times. Well, I know that 36 is 6 times 6. So look at that. We've got 4 6s there. So what do you think I could, let's rewrite that, right? That 1296 as 6 to a power. Right, so now that's equal to log base 6 of 6 to the 4th. And now, whether we have several ways to think of this, we can remember that a log and a base, and the base cancel, leaving the exponent, or we could use the power rule and rewrite that. If we use the power rule, that, by the way, is equal to 4 times log base 6 of 6. And what's log base 6 of 6? Well, that's just 1, right? So because 6 to what power is 6? Well, 6 to the first power is 6. So I could rewrite that as 1. That's just 4 times 1, and that's just 4. So this whole long thing, 4 log 6 of 12 minus 4 log 6 of 2 was 4. That's it. If you have any questions, ask me in class. I have more of these problems that we're going to do in class on Monday. I have a lot of them solved out. Some of them are a little bit more complex, but I still wanted to introduce you to them, as well as some of our little bit simpler problems where we just looked at a single property at one time. All right, so I hope you enjoyed this podcast on the product rule, quotient rule, and power rule. We'll look at more rules for logs in class. Bye for now.